So today we're doing an introduction to probability. So, and the example I used here is that you probably at some point have heard someone say something like there's a 40% chance of rain tomorrow. And the question is, well, what does that actually mean? Does it mean that it'll rain for sure tomorrow? No, certainly not for sure. What's the chance that it will not rain? Yeah. So there's a 60% chance that it won't rain. So in today's lesson, you're going to start talking about the chance or the probability of something happening or not happening. So here's how we've set this up. Mike wants to win a giant stuffed animal at the carnival. He decides to play the Go Fish game, which has 3 prizes: a giant stuffed animal, a smaller stuffed animal, and a plastic kazoo. The game is set up with a tank containing 1 green fish, 3 blue fish, and 6 yellow fish. To play, Mike must go fishing. The game is set up so that every time a player goes fishing, he or she will catch a fish. To win the giant stuffed animal, Mike needs to catch a green fish. So, given the information in the problem, what percent of the time would you expect Mike to catch a green fish and win the giant stuffed animal? Well, how many green fish are there? 1. Out of how many total fish? Right. So as a fraction, that would be 1/10. And what's 1/10 as a percent? It's 10%. So there's 1 green fish out of 10 possibilities that are all equally likely. So part 2 here, what are the chances that Mike will catch a blackfish? 0. There are no blackfish in this. Therefore, his chance of catching a blackfish is 0. That's always possible. If all of the fish in the tank were green, bless you, how would you describe the probability of Mike's winning a giant stuffed animal? Yes.
It's 100% because there are no other options.
Yeah, it's 100%. It would be 10 out of 10, right? So, in the game described originally, you would expect Mike to win a giant stuffed animal 10% of the time. A percentage is one way to express the probability that an event will happen. You might have also said that you expected Mike to win 1 out of every 10 attempts. So the probability that Mike will win is 1 out of 10 because 1 represents the number of desired outcomes. He wants to win the giant stuffed animal. And 10 represents the number of possible outcomes. There are 10 fish, so there are 10 different possible outcomes. So what about a blue fish? How many blue fish were there?
3.
There's 3. Out of how many? 10. The way that we would write that is we say P, which stands for the probability, and then in parentheses, we'll write blue. The probability that he'll get a blue fish is 3 out of 10, which as a percentage is, anybody? 30%. All right, let's find the probability that Mike will catch a yellow fish. How many yellow fish are there? 6 out of how many possible outcomes are there? There's 10. And that is 60%. All right. So these kind of probabilities are called theoretical probabilities because they're calculated mathematically based on what is expected. it may not be what actually happens. He may go fishing 10 times and never catch a green fish. What is the theoretical probability of getting a fish that is either green or yellow? So we want the probability that the fish is either green or yellow. So how many are there of the desired outcome? Yes, ma'am. Yeah, there's 7 fish that are either green or yellow out of 10. So that's a 70% chance. Sam, you with us?
Yes, I'm trying to get to this part, but I can't. You know, I'll just wait.
Okay. Let's move on to the next page. So the spinner below on this page meets the following criteria. 40% of it is red. 1/10 is yellow. 30% is blue. And the rest is green. Well, let's answer some questions here. Which color is the most likely result of a spin? Let's see if I can get some other people that haven't volunteered yet today. Yes, ma'am. Yeah, why? Cadence, why?
Because it's the biggest percentage.
Okay. 40 is the biggest percent. What's another way that we could say that? I'll take a volunteer. I'm getting the same volunteers all the time. Yes, sir.
None of the percentages are more than it.
I'm sorry.
None of the percentages are more than it.
Okay.
Red, and it's bigger on the scale.
Okay. So that's what I was trying to get at was the second part. The red has the most area. So then, what's least likely? Everybody.
Yellow.
Yellow. Ten is the least percent. So let's write out all these probabilities. The probability that it's yellow, as a fraction is 1/10, as a percentage is 10%. The probability that it's red, as a fraction is going to be what? 4/10, or what else could you say? No, just as a fraction. 2 whats? 2/5. It's okay. That's 40%. Probability that it's blue. Thank you. Is 30%, or as a fraction, 3/10. The probability that it's green. Now they didn't tell us anything about it directly, but what do these probabilities have to add up to as a percent? Got to add up to 100%. So what are we missing at this point? We're missing 10, what? 20%. So the probability that it's green is 2/10, which would be 1/5, exactly right, or 20%. Bless you. So what's the probability of it being either red or blue? So the probability that it's red or blue.
70%.
Yeah, it'd be 70%. We're just adding the probability that it's red plus the probability that it's blue. All right, so these are all theoretical. Okay, so you're going to use a spinner in just a second to do an investigation. You're going to use the charts on the next page to record your observations. Here are the steps. Spin the spinner 10 times and record the color resulting from each spin. So over here on this page, under spin 1, you're going to write what color you got. Under spin 2, you're going to write what color you got for that. Next, write the number of times the spinner landed on each color as the numerator of a fraction, with the total number of spins as the denominator. So for right now, that's all we're going to do. So that's these probabilities. These probabilities are all going to be out of 10 for right now. Don't worry about reducing any of them. Okay, so they're all going to be something out of 10. Partly, I like not reducing these because it makes it easier to compare them. All right, so I have for you spinners. Just take one and pass it. Please take one and pass it. All right, so when you're doing this, can I borrow your spinner for a second, please? Thank you. You want to make sure that you put the middle of your spinner on the middle of the circle that you have. You may also kind of have to hold down the plastic because some of these aren't flat anymore. Give it a nice whack. Mine ended up just barely in the red. If you can't tell which one it's on, that's okay. Spin it again. That'll be fine. All right, please go ahead and do that. Excuse me.
I thought
many you actually spun that where red goes on top? I'm sorry. So go ahead and add, how many reds do you get? So again, we want these as a fraction, don't worry about changing percents. So all these, your answers on that second chart should be a number out of 10. All right. Has anyone not finished spinning and recording theirs as a fraction? As a fraction. Okay, ladies. So, question for you. For red, how many would we expect there to be? We'd expect 4. Okay? And for yellow, we would expect 1. For green, we would expect 2. And for blue, we would expect 3. By a show of hands, did anyone get exactly what we expected?
For some numbers,
No, exactly what we expected for the whole thing. Just 1. Okay? So, yours were, thank you, yours were different, most of you, than the theoretical probability, right? So now let's put all these together. So what we're gonna do is I'm gonna go up and down the rows and I want you to tell me how many reds you got. Just reds, nothing else. I can't keep track of more than one thing at a time. I can barely do that some days. All right, so reds, how many?
2.
2,
4.
4,
3.
3,
4.
4,
2. 5. 4. 4. 4.
2,
5. 3. 2. 4. 2.
6.
Okay. So for the whole class, we got 56 out of how many?
60.
160. Let's see, 56 out of 160 is about, well, is exactly actually 35%. All right, let's see how we did for yellow. How many yellows?
2.
2?
1. 1. 3. 1. 0. 0.
1.
1. 1.
0.
3. 3.
How many?
3.
3?
2.
2?
1.
So for yellows, by my count at least, we got 20 out of 180 or 160. I wrote 180, I'm sorry, 160. That's 12.5%. All right, green. I'm sorry, 1?
1, 0, 5, 4, 2, 2. 3,
Yeah.
3, 4, 2, 0, 1, 2, 2.
Two. No, one. Yeah, two.
2, all right. That one is 35 out of 160. Let's see what that is. 21.875%. All right, so let's do blue.
4, 2, 5, 3, 2, 1, 4, 3, 3, 4, 2, 4, 1, 2, 6.
Which is 50 out of 160. Somewhere or another, I'm off one. Because this doesn't quite add up to 160. That's 76, 111, that's 161. Somewhere or another, I either typed something wrong or someone told me a wrong number. It's not important. It's going to be pretty close. This is 31.25%. So what were our expecteds? For red, we expected 40%, right? For yellow, we expected 10%. For green, we expected 20%? Yes? And was blue 30?
Yeah.
Okay, I want you to notice something. If you looked at your percentages, unless you got it perfectly, which did happen once, and that's about how many times I would expect it to happen in a class this size, are our class probabilities pretty close to the expected probabilities?
Yeah.
Yeah.
Yeah. In fact, are the class ones closer to the expected than your individual ones were?
Yes.
So, why do you think that is? Well, if we did this a lot, let's say we spent the rest of the day and we did this 160,000 times instead of 160 times. Yeah, Quentin's like, yeah, that sounds like a great way to spend a day. What do you think would happen to these probabilities? Do you think they would get closer to the expected probabilities or the theoretical probabilities, or do you think it would get further away? Yeah.
It would probably get closer.
Yeah, it's probably going to get closer the more you have. This is an idea that we'll talk about later, but it's called the rule of large numbers. With experimental probability, it gets closer to the theoretical probability the more you do, right? If I flipped a coin 4 times, you would expect it to come up heads twice and tails twice, right? But would you be surprised if it came up heads 3 times and tails only once? No. Would you be terribly surprised if I flipped 4 heads in a row?
No.
Be a little bit surprised, but not terribly surprised, right? But if I told you I flipped 100 heads in a row,
Okay.
yeah, do you believe me?
No.
Either that or I have a trick coin, right? So with probabilities, the experimental probability will get closer to the theoretical probability if we do the experiment enough times. Okay? Any questions about that? All right, you have about 5 minutes. Let's make sure that everybody can find the homework and knows where it is. So let's do that before